Look, if you've ever written even a single line of Python, I bet you've seen it. That dreaded program-ending error message. It's frustrating, right? But it's something we all go through. So in this explainer, we're going to dive into how you can actually handle those common errors so your programs don't just crash and burn. Instead, they become resilient. Let's get into it.
You totally know this feeling. You run your script, you think everything's going great, and then bam, a wall of red text hits your screen, your program just stops dead, and you're left staring at a message like this. This isn't just some random bug, it's what Python calls an exception, and its default move is to shut everything down.
Right? I mean, what if your program didn't have to just give up? What if, instead of stopping, it could see a problem coming, deal with it, and just keep on running? Well, the good news is it can. Python gives us the exact tools we need to build a safety net for our code.
All right, so let's break down what's actually happening here. When your code runs into a situation it just can't handle, like, trying to divide a number by 0, or trying to turn the word hello into an integer, it raises what's called an exception. And that's what brings the whole program to a halt.
And this is the exact behavior we want to get under control. An exception, whether it's a zero division error or a value error, immediately stops the normal flow of your script. It prints out what's called a traceback, which is basically a roadmap that shows you exactly where things went wrong, and then it just quits. It's abrupt, and in a real-world application, it's just not acceptable.
So, to get a handle on this, we've got to understand what an exception really is. It's not just some generic error. It's a very specific signal from Python telling you that, hey, something went wrong while I was trying to run this.
This really hits the nail on the head. Think of an exception as an event. It's an object that Python creates and raises when it hits a problem. So our job as programmers isn't to prevent every single problem, but to learn how to catch that event when it happens.
And the cool thing is, Python has names for all of these common problems. I'm sure you've seen a bunch of these before. Value error when you give a function the wrong kind of value. File not found error, that one's pretty obvious. The main point is, these aren't random mysteries. They're known, categorized issues that we can actually plan for.
So how do we build that safety net we were talking about? The main tool Python gives us is a special structure called the try-except statement. This is where we flip the script, where we stop being victims of our errors and start telling them what to do.
And you know what's so great about this? The logic is actually super simple. You're basically saying, hey Python, I'm going to try to run this piece of code. I have a feeling it might break, except if this specific error happens, like a value error, don't freak out and crash. Just run this other block of code instead. It's like having a plan B for your code.
Okay, let's make this real. The true power of this whole approach really shines when you realize you can set up different plan Bs for different kinds of errors.
So we're going to look at a super simple script. All it does is sit in a loop, ask the user for two numbers, and then divide them. Sounds easy, right? But it can break in a couple of really common ways.
All right, scenario 1. The program asks for a denominator, and the user types hello. Now, normally, that int function would throw a value error and the whole thing would crash. But look, because we wrapped it in that try block, our accept value error handler kicks in, prints a nice friendly message, and the program just keeps on trucking. Okay, now for scenario 2. This time, the user enters real numbers, but they put a 0 for the denominator. Uh-oh. The division itself is going to cause a zero division error. But again, no problem. We have a different handler, a specific except zero division error block that catches it and displays a totally different tailored message. See? We're handling multiple unique problems.
And this is the magic right here. After handling either of those errors, the program doesn't die. It just finishes the except block, loops back around, and politely asks for input again. Our little program is now robust. It can take a punch and keep going.
Try and accept are the bread and butter, for sure. But Python gives us a couple of extra tools that give us even more control. Else and finally.
So let's talk about the else clause. This is for the happy path. This little block of code only runs if the try block succeeds, if no errors happen. And that's super useful because it lets you separate the risky code from the code that should only run on success. The try block does the dangerous part, and the else block handles the victory lap, like printing the result. It just makes your code so much cleaner.
And then there's finally. This clause is an absolute game changer for professional code. Think of it as your cleanup crew. This block is guaranteed to run. I mean, always. It doesn't matter if the try block worked or if an error happened and got caught, finally will run.
This is essential for things like closing files or database connections. You absolutely have to make sure that stuff gets cleaned up no matter what.
So this table just wraps it all up perfectly. You try to do something, you accept an error if one happens, you do something else if everything goes well, and you finally clean up afterwards no matter what. Once you get that flow, you've pretty much mastered exception handling.
So, let's zoom out. Why do we care about all this? Because using these tools fundamentally changes how you write code. You stop writing fragile scripts that only work when everything is perfect, and you start building resilient, tough-as-nails applications. I love this quote from our source material because it just nails it. The goal is to write fault-tolerant programs. Programs that don't just tip over at the first sign of trouble, but can deal with problems and either keep going or, at the very least, shut down gracefully without making a mess.
So I'll leave you with this question. Think about your own code, maybe the project you're working on right now. Where are the weak spots? Where could a user type in something weird and break the whole thing? How can you use what we just talked about? How can you use exception handling to make your next project, well, truly unbreakable?